how would you go about sketching 4x plus 2y then?
Oh.
Nick?
Well, first you would move the 4x, or subtract 4x from both sides. Sorry.
So what is your ultimate goal when you do that?
To get it into y equals mx.
So you're going to change into y equals ax plus b form, or mx plus c, whatever.
I think I just got this.
Okay.
Can I go for it?
Not yet. Nick's halfway through.
So then you subtract 4x from both sides.
Okay, so I'm going to do 2y equals 8 minus...
Or what I did was negative 4x plus 8.
Okay, yeah.
And then you just divide by 2.
Yeah.
And you get y equals 4 minus 2, negative 2x.
Yeah.
Yeah.
And you've got that line.
Yeah.
Alright. That's definitely one way, and you could draw that, yeah. There is another way. T-Ray?
You can find the y intersection the x intercept
Yeah.
by making like x 0 and so it's 2y equals 8
So we can find 2 points which will be on the 2 axes, and that's when, as T-Ray said, when x equals 0, what is y, and then when y equals 0, what is x. Now it doesn't have to be 0 and 0, it could be any point, but 0 is quite often quite a nice and easy one to do, isn't it? So this one would just be 0 plus 2y equals 8, which means y is 4. So we've got a coordinate of 0, 4 that I can plot, and then the second coordinate would be 4x plus 0 equals 8, so that means x would equal 2. So I've got a coordinate of 2, 0. Okay? So then, whichever way you want to go about doing it, we've got our set of axes. So I quite like it in this, do you know what this is called? This is the standard or general form of the equation, not the gradient intercept form, the general form. Okay, so now I can just plot 0, 4, okay, and 2, 0, okay, and that's my line. And I just draw those much easier for you with a ruler because I can't line. But there you go, there's my line.
Oh. I just always get confused with the general, what is it called?
General form.
General form, because I didn't understand how you could just mix it up 0 when you wanted to, but now I realize it's when it is 0, what is
Exactly. And it's like saying, well, I could, sometimes 0 is not the best one to pick because you end up with a fraction or something which then it might be harder to plot, so you just pick any coordinate. Go, well, when x is 1, what is y?
So when for the line y equals 4 to 2x, you would just, you know that 2 goes on the x-axis and 4 is on the y-axis? Like, is that how you...
No, so this one, if I was going to work this way, because this is gradient intercept form, the intercept with the y-axis is 4. Okay, so that's my first point. Okay, this is really good. And then the negative 2, what does that mean? That's the slope or the gradient. Do you know how we do that then? Right?
rise and run?
So rise over run. So what we are saying is that the rise over the run has to equal negative 2. Okay? So we always go left to right on the run, so the run has to be positive, which means we know in this case, because it's negative, the rise is negative, which actually means it's a drop or a fall rather than a rise. So what do? We start at this point and say, well, we can go across 1. How far do I drop?
2.
2. So that means the next coordinate would be at 2. If I go across another 1, I would drop another 2, and that just happens to be where it's on the axis. So I can plot it in that way. What we would do, though, is like we did before, is say, well, for this coordinate, I would be, same idea as over here, what is x when y is 0 again? Oh. that make sense?
Yeah.
Ethan?
I don't get it, or I may have missed this, but how does when it's 2y equals 8 minus 4x, how does it become y equals 4 minus 2x?
Because we, at this stage, divided both sides by 2.
Oh.
Yeah? Could you have done that to start with, by the way?
Yes.
I could have actually, rather than do it with 2s and 4s, I could have actually just divided all of that by 2 and the 8 by 2 as well. And that would have changed it. So keep an eye out for being able to do that anyway. Alright? So, then the question is, right? If I said to you now, show on a graph 3x plus 2y is less than or equal to 12. So now, when we draw a line, those are all the points that equal 12 or 4 or 8 or whatever.
It's the same thing, except pretend that's an equal sign, but then when you plot it.
Okay, so show me on the graph all possible solutions for 3x plus 2y is less than or equal to 12. Right? You can just do a sketch again. It's fine. Go for it. Go on then, Greg.
It's like that shading thing. Is that like that shading?
Like we did on the computer the other day, yeah.
So, what I did was, I found out what x was when y is 0. So I made y 0. It makes x 4.
Okay, so
When y is
3
0.
times 4. So I know that when y is 0, x is 4. So I'm going to put a point there.
And then when x is 4, y is 6.
When x is 0, y is 6.
And then you
So I'm going to draw my line. Okay? So here's my line that represents. What does that line represent?
that's the equal to.
Okay. So the line represents all points equal to 12.
Oh, that's like the border.
Wait,
And
That's
then
the
you,
border. Right.
then-
Ethan, got a question?
yes, I do have a question.
Made x
How?
equals 0.
Yeah.
How? Literally just what we were doing before.
Just like like
So,
x is 0 3 times.
What
3
is
times
x?
0.
What is, sorry,
How's-
y when x is 0? So put 0 in. 3 times 0 is 0, so we kind of ignore that one and go 2y must be less than or equal to 12. So we say one of the coordinates for equals is y is 6. 2y is made 12. Yeah?
Y 6.
Y is 6.
Less than
Y is
that, it would
2 times what makes 12?
Divide-
2 times 6. 2 times 6.
Okay?
divide
And
this.
when y is 0, we can forget about that and say 3x must be less than 12. Or equal to, we're doing equal to, so what will x be if 3x is equal to 12? 4. So we've got those two coordinates, yeah? 4, 0 and 0, 6. So there is the line that is the equation. That's where all those points, any point on that line is where 3x plus 2y equals 12. But now we want all those points where 3x's plus 2y's is less than 12. So which side do we want to
The
keep?
negative.
Left or right? Above or below? Greg?
that one. Or like
Above or below?
the bottom left quadrant, below. Like,
So this side.
yes.
So what I'm going to do is I'm going to shade the region that I don't want to allow to be used. So I'm saying we're not using that region. So it should now be that if I pick any point in this infinitely large region, it should.
Oh,
work.
no.
So if I
Oh,
pick
yes.
a point, let's just pick a point. Now that point can have a whole range of coordinates. Just give me a nice easy one that would fall there. So,
2.
pardon?
2 and 2.
2 and 2. Okay, so that could be 2, 2. So let's just do a check then. all right, that we've got the right side of the line. So we would then do 3 times 2 plus 2 times 2 should be less than or equal to 12. In fact, should be less than 12 because we've gone below the line. And is that right? So 6 plus 4 is indeed less than 12. So we're happy. So this is the region that I want.
So anything so anything in the shaded region is out.
It's out. You cannot use it. It does not match our inequality.
You can also try it just by staying in the equation and doing what I think you did like last class or 2 classes ago.
Yeah.
Since it's supposed to add up to less than or equal to 12, and you've already found the equal to, you can just try something less than 12. So to find it out, I did 10, and then you can just do what you did the first time. So I did greater than or equal to 10, and then I made x 0 and found out what y was.
So you found a new line and found that was below
and
that
if
line.
y was less than what it was with the equal to, then I knew which side it was.
Okay.
So any line that's not the shaded region satisfies the inequality.
Any point. Any point. So this point over here, that could be minus 8 minus 1. Yeah?
Oh.
Does that work?
Yes.
3 times minus 8 plus 2 times minus 1 should be less than, in this case, 12. Okay, so we've got minus 24 minus 2 is less than 12. So that also works. So anywhere below that line. Got it? Okay. Next step then. So this is where we start introducing a whole system of equations. Alright? So if I said to you, find any possible values, or find the region bounded by, should we say, 4x plus 3y is less than or equal to, pick a nice one, 30.
Not 30.
16.
16.
12.
12 again would be, 12 would work. 24 would work. Let's do 24. Do you see why we're going 12, 24?
Oh yeah.
Because we're looking for the ones that divide by, as a teacher I'm going to go, I'll make it easy. If I put 21, it would divide by 3, but not 24. Okay? So I'm going to go, what is the reason? So you need to go for that, but also then, y is greater than or equal to 0. Okay? And,
It's 2 lines. It's not 2 lines, correct?
so now there's 2 lines. Yeah? And 2x, okay, is less than or equal to 6. Okay.
Wait. Okay, don't wait. You don't have to wait, but like, I have a question.
Yes.
So we're not actually; those aren't 3-line equations.
Yes,
The
they
two
are.
Are so the two bottom ones
Yeah.
relate to the top one.
No, they're all 3
They're all just
separate
different
inequalities, 3 separate lines.
Oh.
When you draw those lines, you will be left with a smaller region. Okay?
Oh, okay.
Actually, sorry, I'm going to change this one. I'm going to go 2x, okay, is greater than or equal to 2. I'm going to change that just for a reason. So show me the region where I can select possible x and y values that go together. Okay, does yours look like mine?
Yes.
Okay, so
No, not the shape.
this should cross at, when x is 0, y is going to be 8, this line, and this line when y is 0, x is going to be 6, so it should cross at 6 and 8. Alright, this line is when x equals what?
X equals 1.
1, good, because I'm allowed here x greater than or equal to 1. So that should go to 1, and I've got to have, I'm allowed this side of it. And then this line is when y equals 0, also known as the x-axis. That's annoying. So this is the region that I'm allowed to keep.
I would have been right if I didn't make some basic errors. Instead